Hi everyone. All right, so we're going to actually graph our trig functions. So before we talked about the parent functions when we graphed them a couple lessons ago. Then in the second lesson, we talked about the attributes of the functions. So now we're gonna, ding ding. Now we're gonna put it all together. So what I would suggest you do is start with just graphing sine and cosine first, which I have on the warm-up. And then we're going to take a look at what your movement locations are in regards to some of your functions. So with sine, you're going to start at a midpoint and then go up to a high point, then back to a midpoint, then to a low point, and then back to a midpoint. Then if we were to reflect it, if we make it negative, then what's going to happen is your high points are actually going to become low points, and then your low points are going to become high points. So that's going to be indicated here in this next movement pattern. So we're going to have low, mid, low, mid, high, mid. And then with cosine, so with positive cosine, we're going to start with a high point, because if I do cosine of 0, we're going to get a positive 1, which is going to put us on the top. So we're going to start at a high point, then go to a midpoint, then low point, midpoint, high point, so on and so on. So if I were to reflect a positive cosine, that's going to put us at a low point. And then here, of course, if we have a low point, we're going to be reflected and go up to a high point. So that's going to be reflected and result in this graph down here. So these are going to be your 4 big movements that you're going to have in your sine and cosine graphs. So down below, these are going to be your schematics, your steps, kind of your guide into how to graph some of these functions. Now the steps down here mostly focus on how you're going to graph sine and cosine, but there's going to be some very similar, but there is going to be a little bit of a discrepancy when we're graphing tangent, cosecant, secant, and cotangent. So just keep that in mind. So to start off, we're going to be using our model here that we've been using for these trig functions. Oh my god. So first thing that we're going to do is we're going to start with your midline, which is going to be your D value, which is your vertical shift. So that is going to be the value that's being added or subtracted at the very end. So of course, if it's positive, we're going to go up, and then if it's negative, we're going to go down. All right, and then the next thing, ideally, that you can do is we're going to mark the minimum and maximums of the graphs using your amplitude and the midline. So to find the minimum of your graph, you can do your midline minus your amplitude. And if you want to find the highest your graph is going to go, the maximum, you can do your midline plus your amplitude. And then that will actually help you find the range. So you can use this kind of formula, so to speak, to help you find the range of your sine and cosine functions. And then once you find those attributes, then you can find the starting point of your graph using your phase shift. So that's going to focus on your x minus c or your x plus c, depending on which direction it's going to go. All right, and then when you're calculating the period, just remember that for sine, cosine, cosecant, secant, these 4 trig functions are going to have a period of 2 pi, whereas tangent and cotangent are going to have periods of just 1 pi. All right, and then the next attribute we're going to focus on is going to be, or not really attribute, but graphing. To do the first cycle, we're going to use your phase shift, and then we're going to do the phase shift plus a period. So that's going to help us kind of get a visual of what your graph's going to look like. So I know all this kind of seems like mush right now, but hopefully it'll make a lot more sense when we actually see some examples. So what we're going to start with is just the function f of x equals 6 sine of x plus 2. So what I want to start with is just kind of expanding it so you can see all the components and all the different parts. So this is going to turn into 6 sine, parentheses 1, parentheses x minus 0, plus 2. So with this, you can see, oh, we're going to have an amplitude of 6, a b value of 1, a phase shift of 0, and then a vertical shift of positive 2 or up 2. So that's where your midline is going to be. So that being said, I'm going to go over here and fill in the attributes, and then I'm going to go and actually do my graph. So for my midline, I know for sure it's going to be y equals 2 based on that vertical shift. Then your amplitude is your a value, which is what we're going to start with. So keep in mind amplitude measures a distance, so you're always going to do the absolute value of your a value. So that's still going to be 6, even if it's positive. And then for your phase shift, we know that there is no phase shift, so you could say 0 or none, either are accepted. And then for the period, you're going to do 2 pi over whatever your b value is, since we're working with a sine function. So we're looking at 2 pi over 1, which is just going to give you a period of 2 pi. So here, what I recommend is this is where you're going to actually kind of think about what your scale for your axis is going to be, for your x-axis. So speaking of scale, let's kind of take a look at your graph real quick. So looking at your graph, notice how we give you a scale for your y-axis, but notice how there's no scale that's given on the x-axis, either on the x-axis or below down here. So that's because some of your graphs, you may have to input your own kind of fancy scale. So some of your graphs are going to be itty bitty tiny if we don't do a scale, or they're going to be really massive. So that's why we want to use that scale to kind of give us a really good picture and a good visual of what your graph is actually going to look like. So for your scale, by default, I recommend using a scale of just pi over 2. So that's what a majority of your graphs are going to follow. However, if you are going to get like a really big period or a really small period, depending on whatever you are or have, so this is going to be the period length divided by 4. So in this case, if I were to do the period divided by 4, we have a period of 2 pi. If I divide it by 4, well, that still gives us a scale of pi over 2. So regardless, I'm going to do the scale of pi over 2. All right, so next I'm going to do the frequency. So remember, for the frequency, that's going to be 1 over the period. So 1 over the period, that's going to be 1 over 2 pi. So that's all you need for that one. All right, and then for the domain and the range, so I'll show you kind of the mathematical way to do it, and then we'll look at the graph and just kind of confirm. So for the domain of the cycle, what I would recommend is your minimum value is going to be the phase shift, comma, and then the phase shift plus the period. So if I were to do it this way, so I know my phase shift, I'm just going to do it over here. I know my phase shift is 0, so I'm going to have 0, 0 plus the period, which is going to be 2 pi. So that tells me that the domain of that first cycle is just going to be 0 to 2 pi. All right, and then for the range of the first cycle, so for this, I'm going to do the midline minus the amplitude, and then the midline plus the amplitude. So in this case, let's go back up here, my midline, which is positive 2, so 2 minus the amplitude of 6, and then 2 plus the amplitude of 6. So if I do it this way, that's going to give me a range of -4, 8. All right, so now that I have all the attributes, I'm going to go ahead and now put all this garbage on the actual graph. So to start off, we're going to actually start from the top and then work our way down for the attributes. So I order these attributes in a specific way. So we're going to start with the midline. So I'm going to put a horizontal line at the value 2. So this is going to be the midline y equals 2. All right, and then I'm ready to do the amplitudes. I'm kind of ready to do the different points. So for sine, so since we're in a positive sine graph, we're going to do mid, high, mid, low, mid. So we're going to follow that kind of pattern. So your first point is going to be on your midline since we're starting on a middle point. So I'm going to put a point on the midline. And then, oh, we didn't do a scale. Whoops. Well, we said the scale was going to be pi over 2, so I just need to do my scale. So every other square is going to be pi over 2. So 0, 1 pi over 2, 2 pi over 2 is going to be pi, 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2, and then 6 pi over 2, which is 3 pi. Then over here, I'm going to go to the left, so negative pi over 2, and then negative pi. So when you're putting your points on your graph, we're going to be putting points at every other little column here. So the next point I plot is going to be on the same line as this pi over 2. So from the midline, after this, for sine, we're going to go to a high point. Now to measure that, we're going to reference the amplitude. So we're going to go 6 above and 6 below from the midline for these points. So from here, I'm going to count 1, 2, 3, 4, 5, 6. So I'm going to put my next point up here. Sorry, I had to recount, make sure I got it right. So then from a high point, we're going to go down to a midpoint, and then we're going to go to a low point. So now I want to do 6 below the midline. So 1, 2, 3, 4, 5, 6. And then we're going to go back to the midline, which is the midpoint. So now that I have this plotted, now I'm ready to actually draw my graph. So you want to make your graph, make sure it is nice and curved. You don't want there to be any linear parts or components of your graph. You want to be able to see a clear curve. All right, so this is the first cycle of your graph. So of course we could keep it going. So if I were to draw more, so on the right side I could draw more. And then same on the left, I can go down and do this point and then back to a midpoint. Nope. And it should all connect really nicely. So what's in purple is what's non-negotiable. You have to draw and sketch at least one cycle of your function. Anything more is definitely encouraged, but not required. So what I have in purple, that's the bare minimum. All right, moving on. So now we're going to look at a cosine function. So we're going to follow the same, pretty much similar steps, but there's going to be a couple of differences. So let's start with expanding. So 3 cosine 1 parentheses x minus 0 minus 4. Okay, and then your midline is going to be y equals negative 4. All right, and then your amplitude, the absolute value of your a value, which is going to be 3. Then your phase shift, which in this case we have none, so 0 / none, whatever you want to put. All right, and then the period is going to be 2 pi over whatever your b value is, which in this case is just going to be 2 pi. So based on the period, what that tells me here, I'm going to go ahead and just keep the scale of pi over 2, since we don't have any weird period or anything like that. So I'm going to copy and paste the period from number 1 and just use it for number 2 as well. All right, and then for the frequency, moving on, so we're going to have 1 over the period, which is just going to be 1 over 2 pi. Now for the domain, we're going to do that weird little rule that we had. So the phase shift, which is 0, and then the phase shift plus the period. So in this case, we're just looking at 0, 2 pi. All right, and then for the range, so once again, I'm going to do the midline minus and midline plus the amplitude. So negative 4 minus 3, and then negative 4 plus 3. So what that tells us is we're going to have a range of -7 to -1. All right, so now let's go ahead and plot. So I'm going to start with my midline at -4. I missed. Everything's fine. Excuse me. There we go. All right, and then we are ready to start plotting our points. So what you got to remember is we are dealing with a positive cosine. So that tells us we're going to start at a high point, then a midpoint, low point, midpoint, high point. All right, so from the midline, we're going to start with a distance of 3. So I'm going to go 3 up. So from the midline, 1, 2, 3. That's my first point right here. And then from a high point, go to a midpoint. And then from the midpoint, you're going to go to a low point. So I'm going to go down 3. So that's my next point. And then up to a midpoint. And then, of course, back to a high point. So that's the first cycle. But of course, me being who I am, of course, I always want to do a little bit more. Counting is hard. There we go. So you got a better picture of what your graph looks like, but of course, we're just going to focus on what's in purple. All right, so there's your cosine function. All right, now we're going to move on to our tangent function. So with your tangent function, I want you to kind of take a second, look at the different attributes and characteristics that we're going to find compared to what we did for sine and cosine. So they're a little bit different. So your vertical stretch here is going to be your quote-unquote amplitude. So remember, in tangent, we can't have an amplitude, so we call it a vertical. Actually, that should not be a stretch. This should actually be a dilation. So I'm changing this to dilation because technically you could have a vertical shrink or a vertical stretch. So saying a vertical stretch might be a little convoluted. So I'm going to change it to dilation to be a little bit more all-inclusive to what we could potentially have. All right, so your vertical stretch is, or no, vertical dilation is going to be your quote-unquote amplitude. Your vertical shift is going to be your quote-unquote midline. And then we're also going to include the asymptotes, and then now we're going to still have the phase shift, the period, frequency, and all the fun stuff. So we're just adding in a couple other things and changing a few details. So of course, let's go ahead and expand. So for tangent, parentheses 1, x minus 0, minus 3. Now, of course, you're not going to be required to expand, but I do believe it helps a lot of you, especially when you're first starting out. When you get more comfortable, by all means, you don't have to expand every single problem. All right, so now when we move on to the attributes, so for your vertical dilation, that's going to be 4, which is your A value. Your vertical shift is going to be your quote-unquote midline, which is going to be negative 3. Now, because it's a vertical shift, you're not going to say y equals because that refers to a midline specifically. So because it's a vertical shift, you have to think of it like a vector. You need to give it direction and magnitude. So I'm going to say down 3. All right, and then your asymptotes. Now your asymptotes are going to change based on a phase shift. So in this case, we don't have a phase shift, so the asymptotes are going to stay the same. So for tangent, your asymptotes are going to be your pi over 2s. And then don't forget, k is an element of the integers. Should be a double z. There we go. All right, and then for your phase shift, we don't have any, or there is no phase shift, so I'm going to say 0 or none. All right, and then for the period, now you got to be careful here. We're in tangent, so that means you're going to do 1 pi over your b value. So that means we're going to have pi over 1, which is just going to equal to pi. So in turn, that means your frequency is just going to be 1 over pi. Now, when we come back up here to the period, now we're going to talk about the scale. So the scale, I still recommend you stick to your default pi over 2s, because that'll also kind of make it really clean for your asymptotes, but that's just me. You can technically do whatever scale you want, but I would recommend you just stick to your pi over 2s. So that being said, I'm going to come up here, beg, borrow, and steal my scale for number 2. All right, so what I'm going to do is I'm going to follow some kind of very close and similar guidelines to sine and cosine. So I'm actually going to plot a quote-unquote midline using the vertical shift. Because what's going to happen, well, actually, no, I'll get to that when I get to it. So I'll show you why I'm doing all this. So we're going to start with the vertical shift, which is down 3. All right, and then I'm going to plot all possible asymptotes. So all my asymptotes are going to be at all my pi over 2s. So remember, you got to make them dashed. So at negative pi over 2, positive pi over 2, 3 pi over 2, 5 pi over 2, and etc. Okay? All right, and now what's going to happen is your points for tangent. So if it's a positive tangent, your points are going to kind of go in an upward motion. So they're going to be like a low point, a midpoint, and then a higher point, and it's going to kind of curve through those points. So we really need those 3 points. But if we have a negative tangent, then we're going to start at a high point, midpoint, and then go to a low point, and then it would look something like that if it's negative. So we really need these 3 points to kind of get an idea of what our graph is going to look like. So what's going to happen is this middle point right here, well, close enough. These middle points right here are actually going to be on that midline that I just plotted. The quote-unquote midline. We don't technically have a midline. So over here, what I mean by that is I'm going to plot my middle points. So smack dab in the middle between my asymptotes, smack dab in the middle right here is going to be my middle point. Okay, and then what I'm going to do is now I'm going to use my vertical dilation. I'm going to treat it kind of like an amplitude. So what I'm going to do is now I'm going to go 4 below and 4 above from the middle. So because we're going to be going upwards like that, I want to do 4 below, 4, I can't count. So 4 below, put that point there, and then 4 above, 1, 2, 3, I really cannot count, 1, 2, 3, 4, and then put that point there. So 1, 2, 3, I'm going to double check all these. So 1, 2, 3, 4. So then those are the 3 points that we need for tangent. So once you do that, I'm actually going to get rid of that midline. And what I'm going to do is I'm going to use my lasso tool and then just duplicate and then move it over to get more cycles. Or you can just draw them by hand. It's really up to you. But they're all going to be on the same level. So once I do that, now I'm ready to plot. So you want to make these as curved as possible. I know it's a little difficult to do so. Nope. I'm already struggling. Hello. Wow, terrible. All right, well, let's try this again. I'll take it. Tangent's kind of hard to make it look curved. But close enough. I'll take it. I kind of missed, but close enough. All right. So from your domain, what's nice about your domain, hopefully if you remember, we can actually just copy and paste what we have for the asymptotes, but there's one small little detail we got to fix. Because remember, this is asking us what are all the values we can be in our function. But the asymptotes are telling us all the values we can't be. So what we have to do is we have to put a slash. Because we cannot be equal to those asymptotes. We can be everything but those asymptotes. All right, and then for the range, as you notice, your little tangent graphs over here, they're going to be going all sorts of crazy. You got your little disco curves over here. So they're going to go down indefinitely, and then they're going to go up indefinitely. So what that tells you is that the range is just going to be all real numbers, or negative infinity to positive infinity. So, ta-da! All right, so number 4 has a b value that's not 1, but I actually want to show you a similar problem. And we're just going to do and skip ahead to number 5. I believe this will be way more conducive to your time. All right, so for number 5, now you can see this one's going to go a little cray-cray. So with this one, we already have our equation kind of expanded out, but I still need to take out my b value so that I can actually see what is going on with my phase shift. It looks like my phase shift is actually going to go right pi over 2, but that's not the case. So we have to take out that b value so that we can see what's happening. So what I'm going to do, so negative 4 cosine, I'm going to factor out that 1/2. Or actually here, let me not get ahead of myself. Let's just write it out and then we'll move it to the side. Yeet. All right, so now over here, now we're going to take out that pi over 2. So I'm going to have negative 4 cosine, parentheses 1/2, parentheses, and then x minus pi over 2 divided by 1/2. So this insane, crazy looking fraction within a fraction over here. So that's what we want to simplify. So I'm going to simplify pi over 2 divided by 1/2. Now, when you divide by a fraction, that's the same as multiplying by its reciprocal. So pi over 2 times 2 is just going to give you pi. All right, so what's going to happen? So your equation is going to be negative 4 cosine 1/2 x minus pi plus 6. Okay, so this is really the equation that you're going to want to reference when you're doing your characteristics or when you're doing your attributes. So just to kind of give it a little bit more attention, I'm going to move it way over here so we can kind of reference it over here as we go. So for my midline, I know it's going to be y equals 6, which is my vertical shift. My amplitude, remember, we're looking at the absolute value of your a value because that's measuring a distance. So distance in math cannot be negative. All right, and then your phase shift, so you need to give it a direction. So you need to say right pi. So just saying pi is not going to be enough. You have to give it a direction. If you just say pi, I would take off because I can interpret pi as going right or left. All right, and then your period, so we're in a cosine function. So I want to do 2 pi over whatever my b value is. So that's going to be 2 pi over my b value of 1/2. All right, so when I simplify this, that's going to be 2 pi times 2 over 1, which means we're going to have a period of 4 pi. So because we have a period that's not 2 pi, which is our traditional, our norm, I'm going to put a scale in. So for my scale, I'm actually going to do the period and then divide it by 4. So I'm going to do 4 pi divided by 4, which is going to give us 1 pi. So I'm going to do 1 pi as my scale here. Okay, so frequency, we'll finish these and we'll do the scale. So for the frequency, that's going to be 1 over the period, so that's 1 over 4 pi. And then the domain and range of the first cycle, so let's go ahead and do your phase shift, which is going to be pi, then plus the period. So the phase shift, and then the phase shift plus the period. So what that means is that the domain of that first cycle will be pi, comma, 5 pi. And then the range, so we're going to do the midline minus the amplitude. So 6 minus 4, and then 6 plus 4. All right, so then our range will be 2, comma, 10, based on that logic. All right, so now that we have all the attributes, now let's go ahead and graph everything. So start with the midline at positive 6. I almost did negative 6. Whoops. All right, and then we're going to use our direction. So notice how we have a negative cosine. So positive cosine starts at high, then goes to mid, low, mid, high. Negative cosine, that means we're going to start low, mid, high, mid, low. Okay, so I'm going to start on the midline, and then I'm going to start 4 below. 1, 2, 3, 4. So we're going to start down here. And then we're going to go up to the middle. Did I do the scale? No, I didn't. How dare I? All right, so our scale is going to be pi. All right, so anyways, so a low, mid, now we're going to a high point. So 1, 2, 3, 4. Ooh, barely enough. All right, and then back to the middle, and then 1, 2, 3, 4 below. Then draw your graph. Ta-da. All right, now I'm gonna go ahead and do my extra points, because y'all know me, I'm extra. I don't like that. All right. All right, so there's kind of a bigger idea or bigger picture of your graph. So yeah, there's your disgusting cosine graph. All right, now we're going to move on to your cosecant graphs. So I know these can kind of be a little daunting, but they're not as terrible as they look. Yes, they are. Just kidding. All right, so what I want you guys to start off with is remember that cosecant is the same as 1 over sine of x. So what I'm actually going to do is instead of just going straight into cosecant, I'm actually going to plot, well, no, it's not equal, but I'm going to plot 3 sine of x minus 3 pi over 2 minus 2. So I'm going to start with this graph. It's going to give us kind of the foundation and the groundwork in order to graph the cosecant function. All right, so we're still going to fill in the attributes based on cosecant, but a lot of those attributes are actually kind of similar to the sine graph. All right, so your vertical stretch in this case is going to be your a value, which is going to be 3. That's your quote-unquote amplitude. Your vertical shift, your quote-unquote midline, is going to be down 2. And then your asymptotes. All right, now here's the thing. Your asymptotes are going to change based on the phase shift. So we need to check the phase shift. So that phase shift here is going to change what your asymptotes are. So I'm actually going to go over here to the side. So for your new asymptotes, so what you're going to do is you're actually going to set the parentheses. So you're going to do your b parentheses x minus c or whatever, and you're going to set that equal to your original asymptotes. So when I say the b parentheses x minus c or whatever, I mean you're looking at everything right here in the original function. So I'm going to set the x minus 3 pi over 2 equal to the original asymptotes of cosecant. So that means I'm going to do x minus 3 pi over 2 and set that equal to the original asymptotes of cosecant. So you're going to have asymptotes of cosecant where sine equals 0, and sine is equal to 0 at the pi k's. So that means I'm going to set it equal to the pi k's. And then what you're going to do is you're going to solve this equation for your x value. So now over here, you're just going to add 3 pi over 2 to both sides. So this is going to be x equals 3 pi over 2 plus pi k, where k is an element of the integers. Now, here's the thing. If I were to do x is 3 pi over 2 plus pi k, that means I'm just going to have asymptotes starting at 3 pi over 2, and then at 5 pi over 2, and then 7 pi over 2. And then if I go the other way, that's pi over 2, negative pi over 2, so on and so on. So what I want you to kind of realize is this is actually the same as just doing your pi over 2's. So it's the same as just doing pi over 2 plus pi k, where k is an element of the integers. Okay, so for sure, I would recommend that you start trying to recognize these patterns when it's the same as something that we've already done. But depending on the requirements on the test or exam or whatever, you may need to recognize that these are the same. So for example, if it was multiple choice, I would expect you to answer with the pi over 2's, not the 3 pi's. But for right now, we'll talk about that in class later. So your asymptotes, I'm going to just go ahead and answer it with the pi over 2's. All right, and then your phase shift, so we're going to start at the first point, which is going to be 3 pi over 2. And then for the period, we're going to do 2 pi over our b value, which I believe is 1. Yep. So 2 pi over 1, which is just 2 pi. So that being said, I'm just going to use the scale of pi over 2. So frequency is just going to be 1 over 2 pi. All right, now domain and range, I'm going to hold off on that one because it's cosecant, so we're going to have our kind of U-shapes or bowl shapes. So what I'm going to start with is graphing the sine function. So we found all the attributes. Now let's graph sine. So remember, the end goal is we're actually going to plot and graph cosecant. So I'm using sine to just kind of help. So it's not going to be the main attraction in this case. So meaning what I'm going to do is I'm going to graph sine kind of in the background. I don't want to bring a lot of attention to it, but I want to see it to kind of help me. So I'm going to graph it in gray and make it a dashed function. So I'm going to start with the midline. Actually, I really should start with the scale. BRB. Nope. 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 All right, I'm going to steal you. Come here. Ta-da. All right, so now that I have my scale, back to our daily scheduled events. All right, so for this, now we're going to start our first point at 3 pi over 2. So your first point's actually going to be over here. So with sine, when I graph it, we're going to start with a midpoint. And then we're going to go to a high point. So amplitude is 3, so I'm going to go up 3, then back to the middle, and then to a low point. So also notice how I can't graph a complete cycle. So because I can't keep going to the right, I'm actually going to go to the left. So then I'm going to keep this pattern going, and I'm going to go to a low point, back to a midpoint, to a high point, then to a low point, then, or midpoint, then to a low point. All right, so now that I have that, so now I'm going to graph my sine function. Wow, terrible. Oh my gosh, why can I not draw it today? There we go. All right, so now that I have my sine function plotted, I don't need this midline, so I'm going to get rid of this midline. And now, the next thing I want you to kind of keep in mind, look at the asymptotes, and then look at your sine function. Notice how we're going to have asymptotes at negative pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. So notice what type of points these all are on your sine function. So hopefully you realize that these are all midpoints. So if you have a midpoint for sine, that's actually going to translate to being asymptotes for cosecant. And of course, the same logic applies. If it's a midpoint for cosine, then it'd be an asymptote for secant. So same idea. And then anytime you have a minimum or maximum for sine, that's going to be your location where you're going to have your little bowls. Your little U-shapes, whatever you want to call them. All right, so I'm going to go ahead and start with my asymptotes. So we're going to have asymptotes at pi over 2. Then pi over 2, I missed. 3 pi over 2. And 5 pi over 2. Oh, wow, terrible. All right. So now the next important part is anytime we have those minimums and maximums on our sine graph, so at this minimum, this maximum, this minimum, this maximum, this minimum, these are going to be where your bowls are. So I'm going to put some points on all those values. All right, and then this is where your bowls are going to happen. So I'm going to have a bowl pass through right here and look like this. Then I'm going to have another bowl pass through and look like this. Then we're going to have another bowl over here that looks like this. All right, and then if you look on either end, you're going to see that we also can do some half bowls. So I'm going to go ahead and draw those as well, just so you can kind of get an idea of what your graph looks like. All right, so now that I have my cosecant function graphed, so now I'm going to get rid of the sine function. So I would highly recommend that you get rid of the sine function. However, I'm not going to require it because I want to just focus on the cosecant graph. So now that we just have the cosecant graph, now let's look at our domain in range. So the domain, we luckily enough can actually just copy our asymptotes and then just make that adjustment. So we cannot be equal to those pi over 2s. And now for the range, so remember, we're going to go down indefinitely, but then we're going to stop right here at -5. And then we're going to have this empty space right here, so that means we're going to need a union, and then we're going to pick it right back up again here at 1, and then go up indefinitely. So we want to represent that by doing negative infinity with a parenthesis, going to negative 5, I hope, yes, with a union, or bracket, then union, then bracket, and then we're going to pick it right back up at 1, and then go all the way to infinity. So there's your cosecant function. All right, and then your secant function is going to be the same premise, the same idea. The only difference here is you're going to start with your cosine function. And then same idea. So I'm going to let you guys try that one and then reference the key as needed. And then cotangent is very similar to tangent. So with tangent, I'm going to let you guys just kind of reference the tangent one as you do the cotangent. So what you need to remember with cotangent is cotangent graphs are going to be going down like this. So tangent graphs go up and to the right, cotangent graphs go down to the right. Okay, so if I do a negative cotangent, then that would look like a tangent graph. Whereas if I do a negative tangent graph, then that would look like a cotangent graph that's going down. Okay, so I'm gonna let you guys practice the rest of this at home or wherever. Just, yeah, good luck. I believe in you. Make good choices.